Hello, Math130 students. We are going to pick up on page 19, section 4.6, which is all about factoring trinomials. So here, we want to factor a trinomial with a leading coefficient of 1. Given the general equation of ax squared plus bx plus c, we can use the AC method. So it's really important for us to realize that our a, our b, and our c are just the coefficients in a degree 2 polynomial. So we are going to consider that and put it into this AC method. So what we want to do is we want a times c up on top. We want our original b value down at the bottom. And what we do is we replace this b value with two terms. So then that way our trinomial, our 3-term polynomial, is going to be turned into a 4-term polynomial. And the reason we do that is that we can factor by grouping. So let's think about this a bit more. So here are examples down below. So for number 1, we have x squared plus 7x minus 44. So we can think of that a value as being a 1 coefficient. So now I can say that my a value is 1, my b value is 7, and my c value is equal to a negative 4. So if I'm going to use that AC method to help me out, well, I know that up on top I have to have my a times my c value. So then a times c would be a negative 44. My original b value is 7. So now I want two terms that multiply to 44 and adds to 7. So if you need your scratch work, go ahead and use it. So I'm going to go ahead and use it on the right hand side. So I want something that multiplies to 44 and adds up to a 7. So let's think of our multiples of 44. I have 1 times 44. 2 times 22, 3 does not go into it, and I also have 4 times 11. So the only combination that I have that's going to add up to 7 is going to be 4 and 11. If I do 11 and 4, and I want to get to my positive 7, then it would be a positive 11 and a negative 4. So I would have a positive 11 and a negative 4. And actually, I'm going to change this into a blue. I just want to color coordinate it. So I said I had a positive 11 and a negative 4. So now these are going to represent that new b value. So we're going to replace b value with those two terms. So now I have my x squared plus, that's my b value. This is where I'm replacing it now. I have my 11x minus 4x, and I have my minus 44. So now that I have 4 terms, I can do this by factor by grouping. So now I split it. The first half has an x in common, so I'm left with an x plus 11. The second half has a negative 4 in common, so I'm left with x plus 11. So the common factor here would be my x plus 11, and my leftovers go in its own parentheses, which would be my x minus my 4. So now I know that I have factored completely. So I have my x plus 11 and my x minus 4. Okay. Now I'm going to do the exact same thing for number 2. What's slightly different here is now that I have 2 variables, I have P and Q. I just have to keep in mind what's going on. So I'm going to just get rid of my scratch work here because it's going to be different. So let's think about this. So again, I have that leading coefficient of 1. Perfect. So I have A is equal to 1, my B is equal to 27, and my C value is equal to a 50. I'm going to make my 50 look a little bit nicer. 50, there we go. Okay, so now I'm going to have my A times C value. So A times C, 1 times 50, that's going to be 50. And remember, that was my A times my C. And I'm going to have my original B down at the bottom, which is my original 27. So I want to think about 2 numbers that are going to multiply to 50 that adds to 27. So let's think of all of our multiples or all of our factors of 50. 1 times 50, 2 times 25. 50 cannot be divided by 3. 50 cannot be divided by 4. 50 can be divided by 5. 5 times 10. And those are going to be all of my factors of 50. So I want a combination that's going to add up to 27. So the only combination that's going to work here is going to be 25 plus 2. That is going to give me 27. So since I want a positive 27, it would be a positive 2 plus a positive 25 is equal to my positive 27. So I'm going to write this as a positive 2 and a positive 25. So those are going to be my 2 values that are going to replace that B value there. I'm going to be careful because I don't want to hide my sign. I want to know that that's addition in the middle, okay? And notice, like in our first example, that because this was a 1 coefficient, then that 11 and that 4 got directly placed into my answer. So because this coefficient here is 1, I can directly say that this is going to be x plus 2 and x plus 25. Now, could I have rewritten this in 4 terms? Absolutely, and I would have gotten the exact same answer. But this is the beautiful thing, that when you have your leading coefficient of 1, that when you do the AC method, those 2 terms that you found will go directly into your parentheses. But it's only with the leading coefficient of 1. So you have to make sure that that leading coefficient is 1 in order for this to work out. So now for the next examples, our leading coefficient is not 1. Our leading coefficient is greater than 1. So that little trick that I just taught you won't work. You can still do the AC method, but it won't be copied directly from your that AC chart. So for example, I have 16x squared plus 40x plus 9. So then here I see that my A value is equal to a 16, my B value is equal to 40, and my C value is equal to a positive 9. So I have my A times my C and my original B down here. So A times C, so that would be my 16 times my 9. That'll give me 144. And I also have my B value, which is a 40. So I want 2 numbers that multiply to 144 but adds up to a positive 40. So I'm going to use my scratch paper over to the side. So I have 144. So I know 1 times 144 is 144. And also 2 times 72 is 144. I know 3 times 48 also works. I know that 4 times 36 also works. I also know that 6 times 24 also works. And I also know that 8 times 18 also works. I also know that 9 times 16 also works. And I also have my 12 times my 12. So those are going to be all of the different factors that multiply together to give me 144. Now, out of the complete list here, which combination, which two pairs, or which pair is going to give me a positive 40? So let's see. Well, it looks like 36 plus 4. If I have a positive 4 plus a 36, that will give me a positive 40. So that is exactly what I want. So it's a positive 4 and a positive 36. So those two are going to represent or replace that b value. So I have my 16x squared. And now to replace that original b, I'm going to have a positive 4x, a positive 36x, and I also have my plus 9. So I'm going to split this in half. The first two have a 4x in common, so I'm left with a 4x plus 1. The second half has a positive 9 in common, so I'm left with a 4x plus 1. So that common factor is 4x plus 1. And my leftovers are 4x plus 9. And that ends up becoming my final answer. Okay. Now I'm going to erase that scratch work because I need to go over to number 2 now. So for number 2, I'm looking at this, and I'm looking at 15, 31, and 10. There's not a greatest common factor, so I'm going to go straight into my A, my B, and my C values. So I can see that my A value is 15, my B value is a negative 31, and my C value is equal to a positive 10. So I have my A times my C value. So I have 15 times 10, which gives me 150. I have my B value, which is a negative 31. So I'm going to look at all of my factors of 150. 1 times 150, 2 times 75, 3 times 50, 5 times 30, 6 times 25. Oh, and it looks like I can stop, right? What is 6 plus 25? That is equal to a 31. So here, this combination will work if I have a negative 6 plus a negative 25. So a negative 6 plus a negative 25 is equal to a negative 31, which is exactly what I want for that b value. So I know that I have a negative 6 and a negative 25 that's going to be replacing that b value. So now I have a 15y squared, and now to replace that b value, I have a negative 6y, a negative 25y, and a positive 10. So I split it down the half, and the first two, what they have in common is going to be a 3y. So I'm left with a 5y minus 2. The second half has a negative 5 in common, so that's going to give me a 5y minus 2. So my common parentheses is 5y minus 2, and my leftovers are a 3y minus 5. So now I have my answer as 5y minus 2 and 3y minus 5. Okay. Well, I hope that this is making sense for everybody. I hope it's not too bad, but we do have a couple of more examples just in case you guys are wondering, okay? All right, so I'm going to go ahead and just clear off my scratch work. And so we can begin number 3. So here at number 3, I'm looking at 63d squared minus 63 plus 14. So what I'm seeing here is I see 63. Can 63 be divided by 7? Yes. Can 14 be divided by 7? Yes. So here we are actually going to have our greatest common factor of 7. So I need to do this first before I do the AC method. So I have my 7 that I'm going to factor out. So 63 divided by 7 is going to give me a 9d squared minus 9. And 14 divided by 7 gives me a positive 2. And now my numbers are a lot smaller when I do my AC method. Now I have that my A is equal to 9, my B is equal to a negative 9, and my C is equal to a positive 2. So when I do my A times C and my B value, my numbers are a lot more manageable. So 9 times 2 is an 18, and I have a negative 9. So over to the side, what two numbers multiply to give you 18? 1 times 18, 2 times 9, 3 times 6. And I believe those are going to be all of my multiples. So the only combination that's going to give you a negative 9 would be this one. If I have a negative 3 plus a negative 6, that's equal to a negative 9, which is exactly the B that I want. So I'm going to rewrite this as a negative 3 and a negative 6, which is going to replace that B value. So now I have my 9d squared minus 3d minus 6d plus 2. So I split it in half. The first two have a 3d in common, so I'm left with a 3d minus 1. The last two have a negative 2 in common, so I'm left with a 3d minus 1. So now the common parentheses is 3d minus 1, and my leftovers are 3d minus 2. And I can't forget my GCF from the very beginning that I'm going to drop down as a 7. So now I have my complete factored form. And I'm going to do the exact same thing for number 4. So I'm going to erase my scratch work since I'm starting a new problem. Usually I would just have more sheets of paper for my scratch work, but I can't necessarily do this when I'm doing this on my computer. So let's see, do we have a GCF? We have 15, 38, and 7. Well, 15 can only be divided by 3 and 5, and I have a 7 there, so there's no GCF. So I'm going to go straight into what's my A, my B, and my C. So I see that my A is 15, B is 38, and my C is a positive 7. So I have my A times my C and my B value. So let's see here. 15 times my 7 is going to give you 105. And I have my 38 down at the bottom. So what two numbers can I multiply together to give me 105? So I have 1 times 105. 2 cannot divide it. 3 and 35. Oh, perfect. Because 35 plus 3 would give me 38. Positive 3 plus 35 gives me 38, which is exactly what I want. So I know this is going to be a positive 3 and a positive 35 for my middle term. So now when I rewrite this, I'm going to have a 15c squared, a positive 3cd plus a 35cd plus a 7d squared. So I split it in half, and the first two what they have in common is a 3c. So what's left over is a 5c plus d, The second half have a 7D in common, so I'm left with a 5C plus D. So the common parentheses is a 5C plus D. And my leftovers is a 3C plus 7D. So that ends up becoming my final answer. Okay. So I'm just going to keep going. Hopefully it's, it's starting to sink in a little bit. And if it's not, it's okay. We have a few more examples just to make sure you guys are getting the groove of things. So for number 5, I have 21, 26, and 8. And with this one, I'm going to go ahead and do something called the guess and check. So I can do the guess and check, or I can do the AC method. And we've already done the AC method plenty of times, but I haven't really done the guess and check. Some students prefer the guess and check, and some students prefer the AC method, and it's really up to you to see which method you like better. So if I have 21, 26, and 8, there's not a common GCF, so I keep going on. And so I'm going to think about it this way. So look at the first here. I have 21. So that can be written as 1 times 21, and it can be written as 3 times 7. Then I look at my last, which is my 8. So it's 1 times 8 and 2 times 4. So if I'm going to do my guess and check, I know that my first is going to go here. So I'm going to guess, and that's, my guess and check is sometimes you're just going to have to guess. I'm going to guess a 3 and a 7. And since it's W squared, it definitely has to be a W and a W. Now I'm going to guess the last term. So the last term here, I have some options. I can either do my 1 times 8, or I can do my 2 times 4. I'm going to try my 2 times 4 first and see if that works. So let's think about this. If I were to put a 2 here and a 4 here, let's check if that works, right? So I would have 3 times 7, which is a 21W squared. I would also have a 6W. 7 times 4 is a 28W. And then I would have a 8. So can 6 and 28 give me 26? No, it cannot. It can give you 22, but it can't give you 26. So that was not going to be a good option. So I guessed it, and I checked it, and it didn't work out. But not all is lost. I'm going to try it again. So I'm going to try 3W, 7W. But now this time I'm going to try the 2 here and the 4 here. So I know I've tried that, and it didn't work out. So now let's try this new combination. Let's flip that 2 and the 4. So now I would get my 21W squared. I would get a 12W and a 14W and an 8 if I were to FOIL it out. So if I have 12 plus 14, that does give me a 26. But since I want a negative 26, then it would have to be both negative. And a negative 2 times a negative 4 would give me a positive 8. So now I would definitely have my answer as a 3W minus 2 times a 7W minus 4. And I just noticed that there's a small typo, but it doesn't change any of my work. The typo is that this should really be written as a 21W squared minus 26W plus 8. So this term is just missing the W, okay? But it doesn't change any of my work. And so for those of you who like the guess and check method, you're not afraid of having a messy paper, okay? Notice how I'm trying some stuff It didn't work, so then I scratched it out and then I try again, okay? And if you're like, oh wow, that was really confusing, I didn't understand it, I don't like it, then you can go back to the AC method. That's not a problem. So let me just do one more example with this guess and check. And if you're like, nope, that's not for me, that's fine. You can always do the AC method. I just want to give you guys options, okay? So let's try this guess and check. So I have 35, 18, and 8. There's nothing in common. So I am going to go ahead and go straight into my guessing. So I know that for my first, if I have 35, I'm going to have a 5u and a 7u, since 5 times 7 is 35. And again, if I'm looking at my last, that's 8. So I'm going to look at 2 times 4. And I also have 1 times 8, but I'm going to go with 2 times 4 first. So I'm going to put my 2 here and my 4 here. So now I'm going to check to see if this can be right. So I'm going to FOIL. That is how I check it. So 5 times 7u is my 35u squared. 5u times 2 is a 10u. 7 times 4 is my 28u, and 4 times 2 is 8. So can 10 and 28 combine to give me a negative 18? Yes, it can if I have a negative 28 and a positive 10. So I'm going to have a positive 2 and a negative 4. And negative 4 times a positive 2 is a negative 8. So in this case, I was able to guess it and get the correct answer on my first try. So it really just depends on whether or not you have some number sense and whether or not you like the guess and check. So let's go back to the AC method. Maybe you guys aren't feeling this. That's okay. So if I'm looking at 20c squared minus 33c plus 10, well, they have nothing in common. So I'm going to say that my A value is 20, my B value is a negative 33, and my C value is a positive 10. So my 20 times my 10, since that's A times C, I'm going to have 200. My B value is a negative 33. So again, I like my scratch paper. I'm going to look at my multiples of 200. And remember, my goal is to add to negative 33. So I have 1 times 200, 2 times 100. I have 4 times 50. 5 times 40. I also have 8 times 25. I also have 10 times 20. And I also have my 10 times 20. Okay, I already said that. So I think those are, for the most part, all of the factors that multiply together to give me 200. So which combination is going to give me a 33? So let's see. What about 25 plus 8? Perfect. This is going to be the combination that's going to give me a negative 33. If I have a negative 8 plus a negative 25, that's going to give me a negative 33. And that's exactly what I want. So I'm going to rewrite this as a negative 8 and a negative 25. And so these two are going to represent that middle term there. So I'm going to rewrite this as my 20c squared minus my 8c minus 25c plus 10. So when I split this in half, what I have in common in the first two is, let's see, 20 and 8. I believe that's going to be 4c. So I'm left with a 5c minus 2. I will have a negative 5, and that's going to give me a 5. Oops, didn't write that very nicely. 5c minus 2. So the common parentheses is 5c minus 2, and my leftover is 4c minus 5. Okay. And that is how I end up getting that final answer. Now let's look at number 8. If I'm looking at number 8, I have this 10z squared minus 23z plus 12. So 23 is pretty much a prime number, so I know I do not have a GCF. I'm going to go ahead and do the guess and check, because why not? So here I'm going to guess it and I'm going to check it. So it may be messy, it might not be. So if I'm thinking about the first term, I'm going to think about a 5z and a 2z. The next thing I want to think about is that 12. If I'm thinking about 12, that's 1 times 12, 2 times 6, and 3 times 4. So because this is an even number, then I know it can't be 2 and 6, because I can't have two even numbers in the same parentheses. That would be incorrect factoring. So let's say I want to go with 3 and 4. Well, since 2 is even, 4 is forced to go here, so I'm forced to put 3 here. So let's check, and by checking, I mean let's FOIL to see if this works out. So 5 times 2 is a 10z squared, and I have 5z times 3, which is a 15z. I also have an 8z and a 12. So can 15 be added to 8 to give me a 23? Yes, it can, but only if these both were negative. So if both of those were negative, negative 4 times negative 3 is a positive 12. So I was able to guess and check for number 8. Could you have done the AC method? Absolutely. Would it have worked? Yes. Would you get the same answer? Yes. It's all about student preference. And I just want to show you that both methods have its pros and cons, right? You can like AC, that's cool. You can also like the guess and check method, and that's fine too. You really just have to practice and see what's going to work best for you. Okay, so that is the end of section 4.6. If you guys have any questions or concerns, please feel free to email me or the Math Success Center or our embedded tutor. Thank you.